In 2019, France began tearing down the largest dam ever removed in Europe, a 36-meter concrete wall called Vezins that had blocked the Sélune River in Normandy for nearly a century. By 2022, a second dam downstream was gone too, and within weeks of the last barrier falling, something happened in the river that scientists had spent decades predicting, but were still not fully prepared to witness. Sea lampreys, European eels, and Atlantic salmon, species that had been cut off from the upper Sélune for over 90 years, began appearing upstream. Salmon were detected more than 20 kilometers above where the old dams had stood. Water temperatures dropped by roughly 2 degrees Celsius. Vegetation began colonizing the drained reservoir banks while the demolition was still underway. The research director leading the scientific monitoring program called the early results spectacular, but a peer-reviewed paper published in 2024 revealed something else. While the fish came back almost immediately, some parts of the river ecosystem are recovering on a completely different timeline, and the disconnect between those two speeds is something French scientists are still working to explain. This is the full story, from the century-old dams that strangled one of France's most important salmon rivers, to the 20-year political battle to remove them, to what the scientific monitoring program is now revealing about how quickly and how slowly a dead river can come back to life. Most videos about dam removal show you the explosion and the drone footage and call it a success. This one follows the data more than a decade deep into the sediment legacy that still fills the riverbed, the local opposition that almost stopped the project, the 1.8 million cubic meters of trapped mud, and the scientific evidence of what actually happens in the first 3 years after you open a century-old river to the sea. Every claim in this video is sourced from France's National Research Institute for Agriculture, Food and Environment, the program Sélune Scientific Monitoring Program, and peer-reviewed research published in Frontiers in Environmental Science. This is not speculation. This is what a decade of field measurements actually recorded. But before you can understand what the river is doing now, you need to understand what France lost when those dams went up, and why removing them was one of the most controversial environmental decisions in European history. Sélune is a 91-kilometer coastal river that flows through Normandy and empties into the Bay of Mont-Saint-Michel, one of the most iconic coastlines in France. Before the dams, it was considered the third best salmon river in France. Biologists estimate its natural potential at around 5,000 adult Atlantic salmon per year, spawning in gravel beds scattered across hundreds of kilometers of upstream tributaries. Sea lampreys migrated up the river to reproduce. European eels, a species now classified as critically endangered across the continent, used the river as one of their inland nursery grounds. All of that depended on the river being open from the sea to its headwaters. Then, in the 1920s and the 1930s, 2 hydroelectric dams were built on the lower Sélune. Vezins was completed in the 1930s at a height of 36 meters and a width of 278 meters. La Roche-qui-Boite was 16 meters high, sitting just 12 kilometers from the sea. Together, these 2 walls cut off roughly 90 kilometers of upstream river from the ocean. The salmon population below the dams collapsed to between 200 and 700 adults per year, a fraction of the river's natural capacity. The watershed upstream of the dams, with all its spawning gravel and cold tributary water, became ecologically invisible to the fish that had used it for millennia. Later in this video, you will see what happens when those 90 kilometers suddenly reopen. The timeline is unlike anything European river scientists had fully documented. But first, why it took France so long to do something about it. When you block a river like the Sélune for a century, you do not just stop the fish, you change the water itself. The reservoirs behind Vezins and La Roche-qui-Boite slowly filled with sediment. They hosted toxic cyanobacteria blooms every summer. Water temperatures behind the dams rose, then passed that warming downstream, a particular problem for Atlantic salmon, which are physiologically stressed at temperatures close to 25 degrees Celsius and cannot reproduce in warm water. The dams produced relatively little electricity, 20 gigawatt hours per year from Vezins, a small figure by industrial standards, but they caused large ecological damage. The push to remove them began in the 1980s. A national recommendation to dismantle the dams was issued as early as 1986. The Sélune, the regional water management body, formally advocated for removal in 2005. In 2007, the dam's operating concession expired, and the French government, based on an EDF report concluding it was technically impossible to upgrade the structures, decided not to renew them. The removal process was set to begin, and then it stalled for more than a decade. What France did next would take 30 years of political negotiation, cost tens of millions of euros, involve nearly 100 scientists from 20 research laboratories, and face strong local opposition at almost every step. And it almost did not happen. In December 2014, after a public inquiry had already returned a favorable opinion on dismantling, the French Minister of Ecology at the time, Ségolène Royal, announced unexpectedly that the removal process would be stopped and new expert assessments would be commissioned. The project sat in political limbo for 3 more years. Local opposition was intense. Sailing clubs operated on the reservoirs. Farmers relied on them for irrigation. Tourism infrastructure had grown up around the flooded valley. Signs appeared in the region accusing elected officials of betrayal. A peer-reviewed study published in the journal Geoforum in 2023 documented exactly how the communication between state authorities and valley residents had broken down. The residents felt excluded from the process, and place attachment to the reservoirs, built up over 3 generations, became a political force the state had underestimated. Then, in November 2017, the new Minister of Ecological Transition, Nicolas Hulot, announced the decision to relaunch the removal. Demolition of Vezins began in 2019. The first, irreparable breach was punched through the 36-meter wall on June 12, 2019. A moment described by European conservation organizations as a historic turning point for Europe's rivers. Vezins was fully dismantled by July 2020. Work on La Roche-Quiboit began in June 2022 and was completed by spring 2023. Together, the 2 dams had held roughly 1.8 million cubic meters of accumulated sediment, a massive logistical challenge. To prevent that mud from flooding downstream and smothering the Bay of Mont-Saint-Michel, engineers used a sediment management strategy unprecedented in the history of dam removal. They dredged and stored much of the material in temporary ponds built from in situ sediments, then released it gradually as the reservoirs drained. What happened next took just a few months, and it began before the demolition was even finished. The scientific monitoring program, Sélune, had been running since 2012, years before the first breach. Pre-removal baseline data on fish populations, water chemistry, sediment dynamics, and riparian vegetation had been collected across the entire river system. When the dam started coming down, that monitoring continued in real time, and the data it produced in the first 3 years after demolition did not match the cautious projections scientists had published during the planning phase. Jean-Marc Roussel, research director at INRAE, France's National Research Institute for Agriculture, Food and Environment, summarized the early results with one word: spectacular. Sea lampreys were detected in the upper Sélune within months of the demolition completing. European eels began using the upstream river as habitat. In autumn 2022, as La Roche-Quiboit came down, salmon spawners fitted with radio transmitters began exploring territory that had been inaccessible to their species for more than a century. 2 individuals were detected upstream of the old dams. One of them remained at La Penty, more than 20 kilometers upstream of where La Roche-Quiboit had stood, throughout the breeding season. Transmitter data showed intense activity at the end of December 2022, consistent with spawning behavior. In the spring of 2023, just months after the last barrier fell, juvenile salmon were detected upstream of the old dams. These were parr, newborn fish, the offspring of spawning that had happened during the winter from 2022 to 2023. It meant the blockage was not just lifted. It was already being crossed and used, and fish were reproducing across the river. water temperatures also responded quickly. The research team documented a decrease of approximately 2 degrees Celsius in the river downstream of the former dam sites. This is not a trivial number. For Atlantic salmon, which experience physiological stress above 25 degrees, a 2-degree drop can be the difference between a river that supports reproduction and one that does not. In the context of climate change, where rising water temperatures are expected to push salmon populations further north, Sélune's sudden cooling was one of the most ecologically significant outcomes of the entire removal. Laura Soisson, the INRAE research engineer who coordinated the monitoring program, noted that vegetation had returned to the banks despite the scale of the construction work. Photographs taken by the monitoring team in January 2021, while demolition was still ongoing, show riverbanks at the tail of the old Vezins reservoir covered in green vegetation again. As the water level dropped, a historic stone bridge that had been submerged for nearly a century reappeared above the surface, still standing. And that is where the story gets genuinely interesting. Because what the peer-reviewed research published in 2024 revealed was not just a river coming back to life. It was a river coming back to life at 2 completely different speeds, and the gap between those speeds is something scientists are still working to explain. The paper, published by Piscart and colleagues in Frontiers in Environmental Science in February 2024, was titled with a phrase that became the central finding of the early monitoring: persistent disconnect between flow restoration and restoration of river ecosystem functions. The physico-chemical recovery, water temperature, oxygen levels, nutrient concentrations happened rapidly. The recolonization by migratory fish and macroinvertebrates happened rapidly. But the broader ecosystem functions, the processes that depend on stable riverbed structure, healthy sediment mosaics, and mature in-stream habitat, were recovering on a much slower timeline. The reason was in the muddy. 1.8 million cubic meters of accumulated sediment behind the dams did not all disappear with the dredging operation. A significant portion of the coarse sediment that had built up over a century was still in the riverbed, and the peer-reviewed early assessment of abiotic fluxes, published in 2023, found that current river flow conditions are not strong enough to move those coarse sediments much, with or without the dams. The legacy sediment was staying put. It would reshape the river's gravel structure and in-stream habitat over years, possibly decades, not months. But here is what makes the Sélune story remarkable. The salmon did not wait. The lampreys did not wait. The eels did not wait. The fish pushed upstream into a river whose physical structure was still actively reorganizing itself, whose gravel beds were still in flux, whose habitat quality was imperfect, and they began using it anyway. The second surprise was ecological. Parks and scientific monitoring programs in other dam removal projects, most famously the Elwha River in the United States, had documented recovery timelines measured in years or decades. The Sélune was moving faster in some dimensions and slower in others. A 2023 peer-reviewed comparison between the Sélune and Elwha cases, published by Germain and Lespez, concluded that geography matters, that the specific hydrology, sediment volume, and political history of each dam removal produces a unique recovery signature. There is no universal timeline. There is only what each river chooses to do when the barrier finally falls. The third surprise was social. The scientific monitoring program built into Program Sélune was not just ecological. It included socioeconomic assessment, interviews, surveys, and fieldwork with valley residents documenting how communities adapt when a familiar landscape they have known for generations is suddenly, deliberately transformed. The Geoforum study published by Boucher and Hudson in late 2023 found that ineffective state communication, inadequate consultation, and insufficient recognition of place attachment had created a persistent gap between ecological success and social acceptance. The river came back faster than the community did. That gap is being closed through ongoing engagement. An educational trail was opened in the valley in 2023, Monitoring committees now include local associations, and the prefecture has launched a renaturation diagnosis study designed to rebuild trust. But the lesson is already clear. The hardest part of removing a dam is not the concrete. It is everything that grew around the concrete during the century it was standing. The Sélune monitoring program will continue until at least 2027. 15 years of continuous data across the pre-removal, removal, and post-removal phases will make it one of the most comprehensively documented dam removal projects in European history. What it has already revealed is this. When you take a barrier out of a river, the water responds in weeks. The fish respond in months. The sediment responds in decades. The human landscape responds on its own schedule entirely. And the river that emerges is not the river that existed before the dam. It is a new river, one still sorting out what it wants to be. 2 dams, 100 years of blockage, 20 years of political struggle, and a river that, within weeks of its last barrier falling, started doing what rivers do when you finally let them go. But the Sélune is not the only place where something people built to last a century came down in a single decade. In our next video, we go to a country where engineers released a handful of animals most people consider a pest, into a landscape that had been drying out for 100 years. What those animals built with nothing but mud and sticks is still being studied by researchers who are trying to understand how a creature smaller than a dog rebuilt an ecosystem that cost billions of dollars to damage. You will not look at rivers or the animals that live in them the same way again.